Welcome back. So, in the latest video, we've done the object drawer, and what is that doing? Basically, it's taking in vertices and indexing them. So we've got 0, 1, 2, and then drawing them in a very brief description of what it does. So all we did in this video is, in the video I'm referencing, is create the object drawer, and then create an object drawer called obj, and then create the object and then draw it here. And we did run into a couple of problems. It's good to see how I solved those problems. It did take me a little bit of time, to be fair. It took me about 5, maybe 7 minutes of just, hunting through. Anyway, that's not what this video is about. This one's about being nice and quick. So inside the object drawer, we have a constructor, a deconstructor. We have the GL units for the VAO, VBO, and EBO, and the number of indices. These ones are basically the addresses that are going to be on for the locations on the GPU where the information is going to be stored. So the VAO is the vertex array object. So that's the array basically. The buffer is the vertex buffer object is basically the allocated memory basically for where the array is stored, and the EBO is the exact same thing but for the number of indices. Okay, so go over to this one. We've got the object drawer constructor where we've got the VAO. Everything's just been initialized at 0. We've got deconstructor, which is basically saying if we've got a VAO, then we need to delete it. And then we've got the create objects function. So what we're doing here, we're generating the vertex arrays and then the buffers on the GPU. And then we've got the bind, the vertex array. We're binding the vertex buffer object and then allocating the information. So I'm going to very quickly go through these. GL buffer data, we're doing the GL array buffer. I'll tell you what, I'll quickly go over. This is what I did in the video as well, so if you want to check it out, you can do. We can just see what this function is doing. We've got the target, the size of the data, the actual data, and the usage. So buffer is actually the target. It's a bit strange why it's done it like that. And the first one we're doing is the array buffer, which is vertex attributes. And then we've got the size in bytes of the buffer's object's new data store, the actual data that's passed in, and the usage, which needs to be either stream, static, dynamic, with either draw, copy, or read. Yeah. And you can see the information down here. So what we're doing, we've got the GL array buffer, which is all the vertices, the size of that data, and then the vertices themselves being passed in, and we want it to be GL static draw. And we've done that for the element buffer object as well, which is all the indices. So we've got an element array buffer. If we go back over to this one, the element array buffer is here, vertex array indices. That's what we're using. So we've got the size of that data, we're passing in the data, and we've got GL static draw. So in a nutshell, what GL static draw is doing is passing that information to the shader and storing it on the GPU, sorry, and then you can't edit that data basically. If you were to put dynamic there, you could always manipulate it afterwards. So next part, after we've done the VAO and the VAO, the VBO and the EBO, we are setting the vertex attribute pointer. Now this one is a bit of a strange one. This is very much related to the actual shader. So we've got define an array of generic vertex attribute data. We got the index, which is the location on the shader. We've got the size, the type, if it's normalized, stride, pointer. You've got all this information down here that shows you what it's going to be. Oh wow, it didn't have to be less than 4. Basically, the size is like how many pieces of data there are. So for a vertex, we want 3 pieces of data because there's X, Y, and Z. For a texture coordinates, you want 2 pieces of data because it's along the X-axis and the Y-axis to wrap around that vertice. For 4, that would be like color and alpha. So you've got RBGA, red, green, blue, and alpha. Okay. Type. Oh, interesting. Oh yeah, this is just the type of the data, and then if it's normalized, the stride, which is how many pieces of data there are. So for X, Y, and Z, that's 3, but you might have 5 pieces of information per vertex, but you only want to use X, Y, and Z for for this attribute, and then the next two you might want to use for the what was it called, for the texture coordinates. So the stride in terms of the texture coordinates would be 3, because it has to go through the XYZ coordinate, then get to the texture coordinate, which is U and V. Okay, and then the pointer. Now this is the starter location in that array. So if you imagine you've got 10 pieces of information in a vertex array, you've got X, Y, and Z and UV for the first piece, and then X, Y, and Z and UV for the second piece. The 0 on the end of that is going to be the start location of that. Oh god, this isn't making much sense, is it? Quick. It needs to be quick as well. Okay, so X, Y, and Z. We'll just do it very simple with one of them because that's all we're using at the moment. We can go into more detail when we use it, when we play with the shaders. So basically, 0 is the position on the shader. 3 is the number of values being passed in. GL float is the type, so it's X, Y, and Z coordinates in 3D space. So you need to use a float. GL false is if it's normalized or not, which we don't want it normalized because normalizing a value gives it a value between -1 and 1, and we might be using way more space than that. Size of verts 3 here. That's the stride. So that's basically X, Y, Z. Then that's a whole stride, and then the next stride is this one. Then the next stride is this one. Okay, that's probably the easiest way of explaining it. I don't know why I did it the other way. We've only got 0 there for now, so we don't need to worry. Later on, we'll put more stuff in there, and then we enable that vertex attribute array, which means that if you haven't got this enabled, then you won't draw anything basically. And then afterwards we unbind everything. I probably went into a bit too much detail with this one, but anyway, let's go to the draw function quickly. So after we've unbound everything, which we've done, so we create the object here, and that means that once this function is finished, it unbinds the VAO and the VBO. I mean, basically what this is for is so that you can have multiple objects at the same time on the GPU, and you can unbind the vertex. Well, you can unbind all the buffers on the array so that you don't accidentally use information from different ones. Does that make sense? And then when we draw, we basically just call this, which is already bound and stuff up here, call the vertex attribute array. The EBO, we don't need to call the VBO because it's already been, all the information's already been stored on the and linked basically. And then we draw the elements, triangles, number of indices, unsigned int, which is the type of data that the indices are, and we start at position 0, which will be the first value there. Okay, and then I've gone over to a window by accident, and then we unbind again. So quickly run that and show you what that does. There we go. So that's the drawing in a nutshell. We'll do the same thing for shaders as well. And these are very quick videos.